Thank you so much, everyone, for taking our time and joining this session so early in the morning. So I have got few slides, of course, right? We'll be here together for almost like 2 hours. So I have prepared some slides, but I would appreciate if you can stop me and ask me questions. Okay, we can make it more interactive. I don't mind deviating from the content that I have, as long as it fits under the higher umbrella of machine learning discussions. Okay, so yes, you can stop me anytime and you can ask me questions. You don't have to wait till the end of the session. Okay, so yes, let's get started. As ma'am said, we'll talk about over, at a high level what machine learning is and what are different types of algorithms and how are they different, why and what they're supposed to perform when we um, of course, use them for our for our industry or problem solving questions. But before we get into that, I have a question for all of you. Okay, what do you think would come after 8 here? So you have 2, 4, 6, 8. What do you think would come after 8? You can unmute and say any idea. What do you think would come here?
10.
10. Okay, anybody else? Not sure.
Yes, sir, it is 10.
Okay. Okay, so let's. This is another question for you all. So, what do you think would come after 12 in this case?
Sir, 15.
15. Okay. Okay. So yes. So now, why am I asking you this question? Okay, in machine learning session. So I'm asking you these questions because the machine learning models, okay, are based on such simple concept. Okay, yeah, it takes that concept to the next level, but it is based on this concept. Now here, I didn't give you a formula. I didn't tell you what is 2 plus 2. I didn't ask you what is 6 plus 2 or 8 plus 2, right? I gave you a pattern and you looked at the pattern, okay, and you created that formula in your mind, right? So you first looked at 2 and say, okay, 2, if input is 2, output is 4. And if input is 4, output is 6. And if input is 6, output is 8. So you are trying to create some kind of link between those, right? So formula you're trying to analyze in your mind. And then you say, okay, now I know what, what is the formula, and it is actually adding 2 to the previous number. So adding 2 to the 8 is 10. Now, if somebody else can come up with some kind of other formula, right? You can use integration, differentiation, I don't know, all those concepts, and you might come up with something else which you can prove that it is not 10, it is 11, or maybe it's 18. If you can prove it mathematically, you are right. Okay, so there is no only one way of solving this, right? And same thing with second problem as well. So if I had given you 8 plus 2, okay, that would always be 10, right? It was 10,000 years back and it would be 10,000 years later. But in such case, in these kind of examples, you can come up with something else as well, right? So these type of model, this type of mathematical model where we do not have a specific formula, okay, are called as non-deterministic model in mathematics, okay, compared to where you have a formula. Okay, so now if you talk about the traditional programming versus machine learning programming, this is the difference. In traditional programming, you have input value and you have formula or the rule, right? And then you get an output, right? Like if I ask you like 2 and 8, 2 and 8 are the input and plus is the rule. So 2 plus 8 is 10, 10 is the outcome. But in machine learning, we give you 2 and 4. So 2 is the input, 4 is the output. You come up with a rule saying, okay, it is adding, 2 to the previous number, adding 2 to the input. That's why we get an output. Okay. So with this concept, let's move ahead. So today's agenda, very simple. We'll talk about what machine learning is, and different types of learning that machine can do, right? And then associated algorithms, and then we'll also look at some examples and applications. Okay, so before we begin, okay, question, what is data science? Okay, now data science, as the name suggests, it is made up of two words, right? Data and science. Of course, you need data. Okay, without data, you're not able to perform any analysis, right? But even if you have data, it is not sufficient, right? Now, again, uh, 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 this topic, some of the concept that we generally cover here in data science was developed maybe even 100 years back. The regression was used long time back. But now what we have is we have got a powerful computer. We have, hard disk cost has gone down. Internet has made us easy to capture data. So it is the right time to, perform this kind of analysis. So when you say this kind of analysis, the analysis that we perform on data is, is falls under bigger term called as science, right? And when you get to learn more about it, you will know that, okay, what we know is probably just the beginning, right? A lot of research is going on, but still it's important for us to make some sense out of it, right? There are a lot of data which is lying with companies. Of course, there are some companies which have been able to successfully use those data to be more successful in their business, right? So when you talk about this, we generally talk about Amazon, Google, and Facebook. uh, if you see Amazon, for example, right? What is their business model? They are a retailer, right? They sell product, right? But how many stores they have? Zero. They don't own any product. They don't own any store. Now that thinking itself is so different from traditional retailers' mind, right? When you say retailer, it means that you need to have a shop, you need to buy things in bulk from somewhere, from the wholesaler, and then you sell it to the individual. So you have to invest so much of money in setting up store and buying the goods initially and then selling it, right? That's what the traditional retailing business is. But Amazon has no product of their own, right? Swiggy, again, uh, probably India's largest retail chain, and they don't own any kitchen, they don't own any product, they don't own any stuff from preparing perspective. Of course, they have a delivery team. So how could, okay, Uber, another example, right? They don't own any taxi. How could they become world's biggest retailer, India's biggest restaurant, world's biggest taxi company without owning any product, right? They are managing data. They've been able to capture the data of taxi drivers and passengers, of restaurant owners and people who are looking to buy food, right? Of sellers and people who are willing to buy the product, right? Amazon, if you see, it's just a platform where they have data of sellers and the buyers, correct? So with just managing data, they have become world's biggest companies. And also, these are the companies where we want to work, isn't it? So they are also the world's most admired companies, if you can call them, right? But they haven't they didn't become so in a year or 2 years, right? They actually invested their whole, what you call, money and power and human resource in performing science on data. So now we know that it's a proven technique, companies have used it, but of course not everybody has been able to do it successfully, and that's why there's a lot of scope for other companies to come into this field. Now, why is this becoming so important? Okay, now, as I said, right, the cost of hard disk has gone down, the internet has made it so easy to capture data. They say that 90% of the world's data was created in last 2 years. As a human being, we have history of thousands of years old, right? We have text, religious text, which goes into thousands of years back. But the content that we are creating in last 2 years, okay, okay, is 90%, and whatever we have done till 2020 is just the 10% of the content that we have in the world, right? So look at the data at what rate it is growing. Okay, they also say that, Facebook, people upload about 1 crore photos every hour. Just photos, I'm not talking about videos, comments, likes, shares, all those things. Just the photos they upload, 1 crore. And how do Facebook make money, right? Facebook doesn't charge you anything. They have to maintain big servers and databases to hold all this information. Um, uh, they uh, they have large employee base. They have to pay them salaries. But where are they getting money from? Right? They make money from our data. Right? So they, again, you can get into their business model. You know that they are using our data, okay, and they are making money, right? So what they want us to give them is our data, which we give them happily, right? And we are happy because we are not charged any money, right? We don't lose anything, right? In fact, we are able to connect with our friends. We are able to showcase our expertise, talent, and things to the world. And Facebook is also happy because they are getting data, and using that data they are making money, isn't it? So data can be so powerful, okay, but as I said, this is not this is not often the case, because there are many companies yet to, they all know, okay. So if you talk about 2022, every country knows that this is an important field, but they still don't know how to apply. And that's where the technologies, that's where topic like this, machine learning, will create a lot of talent pool, and companies can use them for their own benefit. Okay, so now talking about the whole concept of data science, where machine learning or AI or big data fits into all this. So see, if I ask you what is the world's most expensive thing, right? So world's most expensive thing has to be our brain, isn't it? Now, if you talk about gold, we have artificial gold, right? We have developed artificial gold, we have developed artificial diamond. So if brain is more expensive than artificial diamond and sorry, than diamond and gold, we should also be able to make artificial brain, isn't it? So artificial intelligence is a approach by human beings to make this artificial brain. Okay, what do brain do? Two things, right? One, it analyzes a lot of things, right? And then it gives you action. Okay, so let's say if you have developed a robot, okay, and a robot is wants to play, you're playing football with robot. So robot has to kick the ball into the goal, isn't it? So before the robot can hit the ball or kick the ball, it has to make decision of which direction to kick, isn't it? Should it be 45-degree east or 25-degree northwest, right? So direction, and also at what speed, isn't it? At what speed, at what direction, okay, what angle, all these things it has to calculate. So that's where the brain comes into picture, right? You're calculating all these things. Now, once you know that, okay, this is the factor, these are the things that it has calculated. Now it has to take that action part, right? It has to kick the ball, right? The kicking is the action which comes from your electronic component, right? Embedded systems. So artificial intelligence is a combination of your machine learning, which is your thinking capability, plus your embedded systems, the way you make those things move, right? So coming to the machine learning part, as I said, it is the thinking capability. And just like we learn, okay, by attending classes, we learn by talking to people, we learn by looking at, say, our parents, our families, our society, movies. So same way, we are also trying to make machine learn. Okay, so let's say if I ask 5-year-old, okay, and 40-year-old, whether it's going to rain tomorrow or not. Okay, let's say 5 years says yes, it's going to rain, and 40 years says no, it's not going to rain. Whom do we believe? Probably 40-year-old, right? Because we trust 40 years with their data, right? When you say experience, experience is nothing but data. So 40-year-old probably is able to understand the climate better, weather better, and they will be able to probably give us better answer than 5-year-old. Probably, he or she has just randomly said something. But let's say it rains tomorrow. Okay, the 5-year-old got it right. Do you start trusting 5-year-old? Probably not, right? So when you're trying to predict future, if you're trying to forecast, if you're trying to understand what will happen tomorrow, right? We can get it wrong. Okay, We can get, it's not that, you'll always get it right. We can get it wrong. See, generally when you calculate what will happen, you will calculate in terms of percentages or probability, right? There's a 60% probability of rain. So you will say, yes, it's going to rain. You will not say 60%, raindrop will come only till 60% and then it will not reach 40%, nothing like that, right? Output is either yes or no. But when we evaluate, we don't evaluate to 100% certainty, right? We evaluate to uh, some percentage, and if percentage is more than 50%, we say it is going to rain. If it is less than 50%, we say it's not going to rain, right? But ultimately, so in both the cases, you have chances of getting it wrong, isn't it? So just because you get one or two decisions wrong, you don't stop believing the 40-year-old people, right? So that's how we have to work with machine learning. And when you get it wrong, you try to see improve. Why did I get it wrong? Okay, so you try to improve that decision making. Okay, you don't stop believing it. Okay, so that's how AI. So generally you'll hear these terms AI, ML, data science, and people use it interchangeably, but there is a significant difference. Okay, AI is both. So AI includes machine learning, and it is your action part, which comes from the embedded systems. You need to have, the IoT devices and things like that. Machine learning is purely based on algorithms where you are making decisions. So these are again based on your statistics, probability, okay. And your deep learning is even more advanced concept of machine learning. The purpose is same, to make decision, but the algorithms that are generally designed in deep learning, he uses some kind of um, concept of neurology. Okay, now in our body, the messages are carried by neurons, and we don't have one single neuron. So if somebody pinches on your fingertip, the message goes to brain, right? It goes through multiple neurons, which is there, in fact almost like millions of neurons. So what is happening in deep learning? Okay, taking the clue from neurology, scientists are trying to develop multi process algorithms. So in machine learning, when you generally mention machine learning, it is one process. Like you take input, you perform the algorithm, and you get the output. But in deep learning, we are trying to take the input, create output one, then output one again goes to second level of analysis, then creates output 3, 4, so on. So by the time you get the final output, it has already gone through 15 to 50 to 100. Okay, that kind of analysis it has gone through. So it becomes little more complex. Again, here you need little more powerful computers. Okay, and some of this concept in deep learning has been a recent thing. Okay, but machine learning has been in use for I would say more than 100 years back. Okay, so so again, so these are improving your decision making capability. Now to make all these decisions, you need data, right data, right? So I always say this: if you have to make a decision whether to invest in the real estate or not, right? You will go and talk to someone who works in real estate industry, or who understands the real estate industry, right? Okay, a person who has spent 50 years or 40 years in IT industry, okay, will not be as capable as someone who has spent even only 5 years in real estate industry. So yes, data is important, but just because data is important, you can't take any data. Relevant data is more important than any data, isn't it? So big data is again a big topic in itself, where it talks about how to connect to different data sources, collect the data, and put them in a format which can be used by your algorithms like machine learning and deep learning. Data science, okay, cuts across all of these. So data science includes AI, includes ML, includes your big data, includes your deep learning. Okay, apart from that, it has few more stuff which is not shown on the graph. It is about understanding the domain. If I'm trying to make a retail decision, right, I need to know what retail business. If I have to make a real estate decision, I need to know what real estate, isn't it? So the domain is also included in data science. Okay, apart from that, you have your statistics, machine, probability. So all of these together is called data science. So science is a bigger word, much bigger word, which encompasses everything. Okay, but our uh, discussion is limited to machine learning for today. Okay, So what is machine learning? So machine learning is about, analyzing lot of data, okay, and not only analyzing a lot of data, we want to identify the patterns. I mentioned you right, when you have 2 4 6 8, you need to understand the pattern. What is the pattern in the data? Okay, and all of this should be done at minimal human intervention. Okay, okay, so that's the key, because see, if you have human being doing this kind of work, obviously human being can do a probably much better job than machine. Okay, and if you have someone experienced, definitely they'll do a better job than machine learning or machine learning models. Where machine scores over human being is, machine can work 24/7 and they can work continuously for 365 days, but human being, we can't work that many hours, and the capability to handle data is much higher by machine, right? So that's why we say, okay, if machine can do it better, why not outsource it to machine, right? It's about, so that, as a human being, we can focus on something else. We can focus on building better stuff, building bigger stuff, and the routine things which can be outsourced, we outsource, right? We don't want to do everything by ourselves. Okay, so I always talk about this example when, let's say, people say that, it's going to replace human being. No, it's not going to replace human being. It is going to replace the way we work, way we behave, the way we approach things, but it's not going to replace human being. Okay, simple example is, we talk about driverless cars, right? And if driverless cars becomes reality and everybody starts using driverless car, yes, you will lose the job of drivers. Okay, we may not need drivers, but imagine the pressure that a mechanic will have. Okay, mechanic, the normal mechanic that we have today will not be enough to repair your car. Of course, your car will break down, isn't it? Even driverless car will break down. You need mechanic. Okay, mechanic's job will not go away, but in fact, mechanic's job is going to be a lot more complex, because there's a lot more system built into it, right? So data scientist, okay, even the mechanics will be hired who are data scientists. So what I'm trying to say with this example is that we want to focus on building better machines, better products, which will help our life, okay, which will help us to do better things, faster things. Okay, so that's the purpose. And to do that, okay, we need, of course, machine learning, where which can analyze the patterns and give us the insights from the data, okay, with minimal human intervention, right? That's why you can automate stuff. And machine learning also depends upon different types of data, right? In today's world, okay, right, we can do better job, but still we prefer machine, because data can come from variety of sources. You have data from audio, video, website and things like that. You have large volume of data. Some are into GBs, and you understand all this, right? Granular level of data, right? Sometimes, okay, you are a retailer, so if you want to see how much product to manufacture, then you will want to combine the requirements at a country level. Okay, so say that, okay, and in India, in December or in January, this is the amount of product I need to make, right? Soaps, if you're a soap maker, so you'll combine the requirements and say, okay, we are going to make so many soaps. But when you start distributing it, right, you have to know how many soaps that kirana store in a small village would need, right? So the your level of data that you need, level of understanding will vary. Okay, suddenly you have to combine them at country level, and suddenly now you are going down to village level. In village also, at shop level, you are distributing. So your level of data will vary, and that's where it's very difficult for human being to do all these big calculations. So you depend on machine learning. Okay, so what is machine learning? Okay, so as we have seen, it's called subfield. It's a subfield of AI, right? It's a subpart of AI. I like this definition, okay, which I took from internet. It says a program or computer program is said to learn from experience E with some class of task T and a performance measure P. And if performance at task T is measured by P improves with E. Okay, so it's like this. When we say a person in BTech first year and compare a person with BTech second year, our assumption is that BTech second year will have more learning, more knowledge than first year. Why? Because they have got more experience. So if I fix experience, okay, and when I say fix, that means let's take certain experience, okay, and we ask that person to do a task T, right? So you take someone from first year and you make them do a certain task, okay, and then you note on the performance. Okay, the performance is P. Let's say you give them an exam in mathematics and you note on performance. Okay, performance is 75%. Now same task, okay, you give to somebody who has higher experience, same problem, okay, you give it so task is not changing. So when you give the same task to second year student, okay, so you expect the second year to do it better, isn't it? So they'll probably do it, they will get 78% or 90% or 85%, whatever. So in that case we are saying that the machine or program is working. So if you run a program today, okay, and it gives you certain accuracy, and if you run the same program tomorrow, okay, it has to give you better accuracy, right? So again, going back to the first example, if you do 8 plus 2, okay, 8 plus 2 today, if it is 10, tomorrow also it will be 10. Okay, after 100 years also it's going to be 10 only, it's not going to change. So this is not an example of computer programming, it's sorry, machine learning. It is a computer program, but it's not a machine learning program. Your machine learning program with more data, experience is data, as I said, right? As you provide more data, your accuracy will increase, your prediction capability will increase, your forecasting capability will increase. So if your algorithm is going to give better result, then it's a machine learning. Otherwise, it's not a machine learning. Okay. So same example. Okay. We discussed, right? So you are trying to find a pattern in the data, right? With more knowledge, you'll be able to find a clear pattern, right? Now, if I had given only 2, 4, right? If I had given only 2, 4, answer could have been 6, could have been 8 also, right? 2 power 1, 2 power 2, 2 power 3, right? But I give you more data, so you are refining your understanding, and finally you have come up with only one conclusion, that it has to be adding to 10, right? So this is what experience will do to your data, okay? Or rather, data will do to your experience. It will help you to make better decision, isn't it? So if program is able to make better decision, we say it's a machine learning program. So that's how classify a machine learning program with non-machine learning program. Now coming back to the topics of learning, what are different types of learning? Any questions so far? What we have done is basic, and probably most of you would know things that we have done so far. Now I want to get into the learnings of how we learn and how do we make machine work and make decision. All good?
Yes, sir.
Okay, perfect. So I take, yeah, thank you so much, ma'am. Okay, so types of learning, as I said, right, we talk about machine learning, right? Machine learning is when you're making machine learn and act like us. Okay, now when we talk about human learning, right, we have classroom based learning, right? When we have a teacher and whatever teacher says we believe, isn't it? And classic case is that when we are kids in LKG, UKG, we are taught that sun rises in the east, right? And we believe, and we always say sun rises in the east till you go to class 8 or 9, when they say that no, sun doesn't rise in the east, actually earth is moving, revolving around sun. So now you change your thinking that okay, now sun is revolving, sorry, earth is revolving around sun, and that's why we have day night. But later when you go, maybe higher classes, when you go, you realize that everything is moving. Okay, earth is revolving around sun is revolving around, these days because of internet, and even the kids knows, okay, even LKG knows. But during our time, I came to know much later that everything is moving. We have something called as galaxy, and you have universe, and everything is moving, right? So the example I'm trying to say is that you have a supervisor, you have a trainer, you have a teacher, and teacher, okay, is someone who knows more than you, at least in that subject, right? And they are supposed to tell you what is there, right? So we learn by teachers. So that's called supervised learning, okay? But again, if you look at our human beings, right, the things that you'd have learned from teacher is probably 30%, okay, 25%. Other 60, 70, 80% is that we learn from environment. No one tells us do this, do that, right? But we learn when you watch a news, right? You watch a movie, right? You make some opinion when you see something happening around you, right? You make some opinion, right? So that is a learning. That is called unsupervised learning. Okay, but there is a difference between supervised learning and unsupervised learning. In supervised learning, you know things better, okay, than unsupervised learning, but then we'll learn more things from unsupervised learning, isn't it, than supervised learning. So I'll just give you an example here. So let's say I fill a room with 4 fruits: apple, banana, cherry, and mango. So there's a room filled with 4 types of fruit. Okay, apple, banana, cherry, and um, mango. And I keep 4 bags in the 4 corners. I labeled them with apple, banana, cherry, mango. I tell you, okay, segregate the fruits. Okay, put all banana in banana basket, apple in apple basket, cherry in cherry basket, mango in mango basket. Okay, since you've been taught, right, we know what apple is, what banana is. You'll not ask what is apple, what is banana, right? You can easily pick the fruits. Okay, you'll be able to put them in the basket, right? So supervised learning, because you know what apple is, you know what banana is. We also call them as label data. Okay, so the output that you talk about is labeled. Okay, it says banana, so you know what banana is, and you are putting in banana basket. Let's change the same example. In the same 4 fruits, I give it to you, okay? But let's say that you have never heard them or seen them before. Nobody taught you what apple, banana, cherry, mango is. Okay, so you have same 4 fruits, but for a minute, okay, you forget that you have ever seen those fruits in your life. Okay, can you still put them in different basket? Okay, let's say that label is not there. You still have 4 different basket, okay, and we have not put the label. Can you put the 4, can you segregate those 4 fruits in 4 different baskets?
Yeah, not possible.
You can still do that, right? Because these 4 fruits are different, right? In the shape, size, color. Banana has different shape. Cherry is again smaller in size. Mango has different shape, right? So based on the characteristics, based on shape, size, color, various other factors, okay, you can still segregate them. But you don't know that this fruit is called mango, right? You don't know, you can't say that its fruit is mango or this is banana or this is apple, but you can still segregate them. Okay, that is called unsupervised learning. So unsupervised learning is you don't know, why something happens that way. Let's say classic example is, you light a matchbox, okay, it catches fire. So we all know that when you have a matchstick and rub it against matchbox, it gives fire because we have seen. But if you do not read about friction, you don't read about what chemical it has, you won't be able to give justification why that's happened, right? So learning to make fire is unsupervised learning, but what is the science behind it? How, why it happens? If you have to make your own something similar, if you have to make a lighter like object, you need to understand the concept, right? So somebody has to tell you what friction is, what the chemical does, and that you need to have oxygen and all those things for a fire to catch, right? So what you learn by seeing is unsupervised learning, which is again possible, right? uh, Supervised learning is where somebody teaches you, right? And both has its own advantage, right? You can't have some teachers sitting with you for 24 hours and telling you each and everything. We have to use our brain. That's what when somebody says use your brain, what does that mean? The person is telling you to perform unsupervised learning, okay, and try to understand what's happening, right? Now that we have textbooks and all those things, right? But before textbooks, somebody would have thought about it, right? Would have converted that unsupervised learning into supervised learning, which we are reading as a textbook, right? Still, there are a lot of things we don't learn. We learn beyond textbook. Okay, so machine also, okay, and machine also learns. How do they learn? With data, right? So the supervised data will have output column, or labeled column, and unsupervised learning will not have output column. So I will talk about different types of algorithms, okay, after a few slides. So I'm going to explain the difference between all of these, okay, and then I plan to talk about two examples of supervised learning itself. Okay, so I'm not going to cover unsupervised learning in detail, okay, but we will talk about applications for each of these. Then semi and weekly supervised. Semi weekly, it's like mix of both supervised learning as well as unsupervised learning. Okay, so here you might use supervised learning. Okay, supervised learning alone may not be able to give you the final outcome, so you might be using unsupervised learning as well. So it's a mix of both. Okay, third main type of learning is called reinforcement learning. Okay, reinforcement learning is what we call as learn by experience, right? Or learn by doing. Okay, so again, like when you were kids, right, when you did something, your parent would have scolded you, right? Or for some things they would have praised you, right? So when they scold you, they they want to tell you that don't do that. That's why they scold you. Parents, teacher, okay, anybody, when they scold you, they tell you don't do that, right? Okay, um, so it's a purpose of scolding or giving feedback. Okay, it's a feedback based, so you're getting a feedback basically. So feedback, so you perform something and you get a feedback. Feedback means if feedback is good, okay, everybody appreciates, you would be doing more of that. And if feedback is bad, people don't like it, you will stop doing it, right? So so that's the learning that we do, right? When you play a chess, right? When you play a chess, and how do we play a chess? We think of multiple moves, right? And then we calculate, evaluate the impact of that move. If I play this move, what will happen? And what if I do this, then what will happen? So you will play a move which will give you maximum benefit. Or let's say if you're cornered, you'll play a move which will give you minimum loss, right? So what we're trying to do is we're trying to find the move which will benefit us maximum. You have multiple moves to do that, okay? But you do one that gives you benefit, okay? That's called reinforcement learning. And we'll talk about examples. See, the driverless car that we spoke about falls under this kind of learning. So next few slides I'm going to skip. This is what it has, whatever I explained, it has in some detail, so you can refer them. Okay, and straight away we will move to some of these algorithms. Okay, we are almost halfway through. Okay, maybe after 10 minutes we'll go for a maybe 2 minutes of break. Okay, and then we'll come back. So what we have seen so far is what machine learning is, right? And what are different types in machine learning. So we spoke about supervised, unsupervised, semi-supervised, and reinforcement learning, right? So these are the ways algorithm will learn, right? And we'll get in details, okay? As we go down, we'll talk about in more detail. So that is learning. Second type, okay, at the third level that you see, it's called what is the outcome type. Okay, now again, if you have learned about data types, you would know that we have multi types of data, right? We have text data, we have numeric data, you have categorical data. So we are not talking about text for today. We'll talk about your numeric data, okay, which is continuous. We call them continuous, right? Continuous because you can have any value. So if I ask you what is going to be the price of this land, right? It can be anything, right? Okay, so it can take any number. That's why we say continuous. Categorical, which takes value from a group, right? So if I ask you whether the customer will buy or not, so two options, yes or no, that's it, right? You can have multiple, you can have 10 options, okay, but still your outcome will be one of those 10 options only. It cannot be 11th or 5.5 kind of option. Continuous, it can take anything. So that's the the type of data that we generally deal with. And then what is this target variable? What is the purpose of target variable? Okay, target variable is the outcome variable. Okay, the output that you want to see. Okay, the output that you want to view. So when we are trying to predict something, right? Machine learning, as we discussed, that we want machine to predict something for us. So the value that you are trying to predict, they are called as target variable because that is our target. Okay, in mathematics we write y equal to a plus b plus c, right? So y is the target variable. This is, y is what we want to find. So sometimes, not sometimes, we generally represent target variables with y because that's how we write in mathematics, isn't it? So that is what we are trying to find or we are trying to predict. Okay, based on the features or the values that we know. Okay, now you can only perform these situations where your input value impacts your y, right? So if y is a plus b plus c, and if I give you d equal to 5, it is of no use to us, isn't it? So before you perform those analyses, you need to figure out that input values does have impact on y. Okay, if it has impact on y, only then you apply. But the families of algorithms, okay, now let me introduce a term, families of algorithm. Okay, families of algorithm, okay, depends upon, okay, what is the target variable, what is that you are trying to predict. If you are trying to predict continuous target variable, okay, numeric variable, under supervised learning, under supervised learning is where you have the y value. Y value is clearly defined. Okay, so example, so you have house price prediction. Okay, before house price prediction, let's take one more example. Marks versus number of hours you study, right? So let's say that number of hours you study versus the marks that you get, they are related. Okay, they can be positively related or negative related. Okay, directly proportional or inversely proportional, but they are related, right? So what is that we are trying to predict? We are not going to predict the number of hours you are going to study because that is in your hand. As a student, I know how many hours I can study. If I want to study for 10 hours, I can study for 10 hours. Just that I don't want to do, that's a different thing, but I can do it, right? But marks is not in my control. I can't control the marks. So what we do, we try to control factors which will help me to indirectly control marks. So marks become your target goal, target variable, y. Okay, and that y is dependent number of hours you study. Okay, maybe number of hours you play. Okay, it also depends on number of hours you watch Facebook, right? Number of hours you play a game on Facebook, right? That also impact. Just that it has a negative impact. Okay, so these factors which impact your y are called features. Okay, but the algorithm that we decide is based on the y, the objective. Okay, if y is a target variable, is your numeric, okay, that's when we use regression family of algorithm. Okay, so regression again is a family. There will be hundreds of algorithms within regression. Okay, but now we know, okay, we have kind of classified it. Okay, you want to know the housing price prediction, you want to predict the price of the house. Price of the house is a numeric value. Okay, I want to predict marks is a numeric value. Okay, I want to predict how much will be the sales tomorrow, or numeric value. So if I have to do that, I need to use a regression algorithm. Okay, so this is your first family of algorithm that we are talking about, which is called as a regression. Then the second family of algorithm, which is under supervised learning, which is where you have a y value. Okay, so okay, coming back to the first example itself, I wanted to tell you how supervised different than unsupervised. So in this case, okay, I want to predict the marks based on the number of hours I study. So you need to find the relationship, right? I have not written the exam. If I have not written the exam, how do I know the relationship? So what will I do? I will go to my seniors. Okay, you talk to your seniors. Generally, what we do, right? We ask them which subject is difficult, which subject is easy, how to read this chapter, how to read this subject. Okay, I don't understand. How can you tell me a easy way to understand this? We go and we talk to seniors about those things. Okay, because seniors have gone through it, so we go to them. So you go and ask them, okay, how many hours should I study to get 80% marks? Okay, or rather you go and ask them, how many hours did you study? They'll tell you, I studied for 8 hours and I got 70% marks. Somebody will say, I studied for 9 hours and got 50% marks. Somebody will say, I studied for 3 hours, I got 75% marks. Right? So you make that list. That is your data. And data, okay, you have input, which is number of hours that they're saying, and the marks that they have got is your y. Okay, so that's how you have the output here. Okay, you don't have the output that you're looking for. I'm looking to predict for myself. I'm trying to predict for me and my friends. Okay, for which I have to wait till the exam, but I should be able to predict based on what my seniors have done. So when you take the past data, you have clear-cut Y column, okay, target column. And on all these examples, we're talking about single column, a single target variable. Your input variable, your features can be plenty, many, right? Like for marks, it doesn't depend just upon your number of hours you study, right? Number of hours you study, number of hours you play, number of hours you watch Facebook, number of hours you go and do swimming. Some of these things may or may not impact. So even if they impact, you have multiple input values which can impact your output value, isn't it? Or your target variable. So your target impact can be created by many. So you have many features, but you'll have only one column or only one set of data which you're trying to predict. So in housing price prediction, our first example, we're trying to predict the what will be the price of this land or this house after 1 year, 2 years, 5 years, or how much marks will I get if generally I study 6 hours a day. How much marks can I get? That is your objective. That is what you are trying to predict, and you have the past data which tells you. Again, compare it with what the fruit example that we did. You are working with fruit, but you know what fruit is. You know that, okay, this is apple, right? So here you know the relationship. Okay, if I study for 4 hours, I'm going to get 55% marks. That's the correlation that you have created. So you have a particular Y column which tells you the output. Just that you are extending that to your specific case. So that's why it's supervised, and that's why it is continuous target variable. And if it is supervised algorithm, and if it is supervised because you have Y value, your data has Y column, and it is continuous. Y is continuous, numeric. Then you need to use a regression algorithm. Now coming back to the next example, second column rather, your target variable is categorical value. Still you have Y, but Y in this case is not a number. It is yes, no, A, B, C. Okay, high, low, medium. Okay, how much should I pay? High, low, medium. What is the cost? High, low, medium, right? So these are the values, gender, male, female, right? So that's a categorical value. Okay, it need not be 2 or 3. It can be 5 classes also. Multi-class means the the unique values that you have in that group can be many, more than 2. Okay, but ultimately the answer is going to be one of those given values only, right? In that kind of situation, we use classification. We use classification. Okay. Example here is medical imaging. Okay. Now, doctors will ask for medical image, right? They'll ask you to get X-ray done, right? You go and get the X-ray. Now, looking at the X-ray, doctors can decide whether, okay, when I say doctor here, algorithms can also decide whether you have, or the person has problem or not, right? Let's say you fell and your hand is paining. So looking at the X-ray report, doctor will decide whether to put a plaster on you or just give you a simple band-aid, right? So, to do that, okay, doctors should have learned, right? When they are doing their medicine, they are taught by their faculty, by their teacher, to see multiple x-rays, and they tell you, okay, if this is like this is the case. If this is like this, okay, look at this area, look at that area. So that's the supervised learning for doctor. Similarly, when we try to do same thing with machine, we first provide lot of x-ray report to machine algorithms, lot of x-ray reports. We tell them that, okay, this is one data, and if this data has 10% problem, this data has 50% problem, this data. Okay, so we are training. We have to train algorithm with input data. Okay, and once you machine knows about it, then it can take a new one and can predict it for you. Okay, so medical imaging, if you have to use algorithms to predict whether surgery is required or not, whether plaster is required or not. Okay, so answer is yes or no. Surgery required, yes, no. Plaster required, yes, no. Okay, so it has to be done using your classification kind of algorithm. And again, in classification we have many algorithms. Okay, then coming to unsupervised algorithm. In unsupervised algorithm, you don't have why. We don't know the label, right? We don't know the outcome. There's no yes, no. Okay, and here you have two types of algorithms which fall under this. One is called clustering. Okay, let's talk about clustering. What clustering means. Okay, example here is customer segmentation. Right, when you log into Amazon, okay, and when you log in and when you see your home page, there will be an option called as customers like you have also bought, and then it'll give you a list of products. How did Amazon know customers like me? Okay, so exactly like unsupervised algorithm. See, I'm not saying that I am a kind of shopper. I'm B kind of shopper. I'm not declaring. Unlike your supervised, where supervised you are saying, if you study for 5 hours, you get 45 marks. Okay. If image is like this, it is no. Surgery is not required. But here there is no outcome. Okay, that if you have this kind of characteristics, you are a heavy shopper or light or shopper or medium shopper. There's nothing like that. Okay, so what algorithm will do is they will look at your characteristics. Okay, how many hours do you spend on Facebook? Sorry, Amazon. Okay, what kind of products you buy? Whether it's you buy all kinds of product or you buy very specific kind of product, like when you buy only dresses, you don't buy anything else. How much money you spend, okay, what kind of product categories that you buy, right? So these are the characteristics. Based on these characteristics, algorithm, okay, the Amazon algorithm will classify you in a group or cluster you as part of a group. Will say, so here you don't need to know the names of the fruit, apple, banana, right? You just say A, B, C, D. So they will take my data and classify me as category A. Okay, then we'll take your data and take again same kind of characteristics. And if there's a match between your characteristics and my characteristics, then you'll also be put in group A. Otherwise, you'll put in group B. Similarly, it does for all the customers and people who are in similar group. Let's say we both fall in same group, then whatever I buy will be shown to you as a recommendation. We call them product recommendation. So it'll say people like you have also bought this, and what you buy will be shown to me as a recommendation. Okay, so you are trying to segment the customers into various groups, okay, based on the characteristics. Okay, and there's no label, so you're creating your own group category A, B, 1, 2, 3, 4. In algorithms that we use will classify as 0, 1, 2, 3, 4. Right, 4 means you have 5 different types of output. Okay, so here you cannot have continuous target variable, okay, in unsupervised learning. But yes, you are creating categorical kind of thing. You're creating categorical kind of output where you don't know the names, but you know the group. You can give your own name, like 0, 1, 2, 3, 4, A, B, C, D. You can give your own name. Okay, so that's the customer segmentation. Okay, now if you talk about say retail stores, right? Shopper stop. Now shopper stops will have plenty of stores across India, right? 500, 700 stores across India. Do you think it is possible for somebody to manage all the 700 stores? Okay, you need to have 700 people sitting in the head office managing 700 stores, isn't it? Not possible to hire 700 people for manage the stores. So what they do is they will look at the characteristics. Okay, characteristics means what is the daily revenue, what kind of products are getting sold. Okay, so there could be a store which is in Guwahati, And that similar characteristics, there's a store in Mumbai also in some location, and then there's a Chennai also same location. That means they have same characteristics. Okay, the kind of people that go there are similar. The kind of product they buy is also similar. Okay, so what Shoppers Stop will do is they will not look at 700 stores as a separate store. Based on the characteristics, they will group them into 10 or 15 stores only. Okay, maybe stores near to universities, they have specific kind of requirement, right? They probably, if you talk about grocery store, they'll probably buy smaller packets, right? You buy smaller packet of toothpaste, unlike you when you go home, you buy bigger packet because you have more family members at home, so you buy bigger bread, bigger packet of toothpaste, bigger packet of oil. But when you are in hostel, probably you buy a smaller size, right? That's, you're only one to use it. uh, the 40-year-old will buy different, your father will buy different kind of dresses, you will buy different kind of dresses. So they are tracking all these characteristics automatically, of course, not any human being sitting and doing that. They take these characteristics and then based on that they group the store. Okay, so a group can have 50 stores in it, a group can have 30 stores, okay, based on the characteristics. Now they will have 10 people to manage these 10 groups. Okay, not 700 people to manage 700 groups or 700 stores. You'll have 10 people who will manage these 7 or 10 groups, and they make decision for the store. Whatever decision they make, all the stores in that group will have to fulfill. Okay, so they don't plan at each store level, they plan at each cluster level. You call them as cluster. Okay, they plan it, or you call them as uh, store segmentation. Okay, store clustering, store segmentation. They plan at each store level. Okay, so that's why machine learning helps them to make better decision. Okay, and make their life easy. Right, as you grow bigger and bigger, you want to make this thinking or decision capability also automated. That's where machine learning is helpful. The fourth type of algorithm is association, where you're trying to find the association between two products. Okay, so classic example is market basket analysis. You will hear this, right? Um, the stores, they will say, okay, if you buy um, uh, atta, you get what do you call sweet powder free. If you buy 5 kg of potato, you get 1 kg of tomato free, right? If you buy this, okay. So how do I arrive at the product? Okay, which product should be bundled together? Okay, so they find the association between them. Okay, so what they do is they go through each bill of the consumer, right? And let's say out of 100 bills, okay, I'm just giving you a example. Out of 100 bills, 60 bills have bread and milk together. Like 60 people have bought milk and bread. That means there's a very high association between milk and bread. Okay, that information is given to the shopkeeper saying that, okay, there's a high association between your milk and bread. Now what decision they take, right? So generally you'll see that products are which are highly associated, they'll be kept together. Okay, because let's say you go and you plan to buy only milk, but then you see bread and you feel like buying bread because you want bread and milk together, right? Milk and tea together, right? So they put these things together. So retail store, every decision that they make in store, there's a logic behind it. They just don't put anything anywhere. Okay, their aim is to maximize the sales, isn't it? That's the your business has only two objectives, either to maximize sales or minimize cost, right? And when talk about sales, their job is to make sales, I mean higher the maximize sales. So how do you maximize sales when your customer, instead of buying one, they buy two? So how do you make sure that they end up buying two, not just one? And even if they buy, you want them to buy the high product or high margin product. Okay, so when you have these candies and things which is near to point of sale machine, cash payment machine, those are the products which have very high margin. Okay, so they want you to, while you're waiting, okay, they want you to buy these things. Okay, so generally the products which have high margins will be kept near store, sorry, the payment machine, so that while waiting, you tempt to get buy those. Okay, so here we're trying to find association, and then you can make a decision. Decision could be to put them together on the shelf. Okay, um, um, bundle them together and give discount. So there's a classic example where in Japan people figured out that milk and um, beer had a very strong correlation. Okay, or a very strong association. Okay, people who were buying milk were also buying beer, so they didn't realize why it's happening. Okay, there's a 7-Eleven store. What they do, they are very small stores, so they try to look at the kind of customers that they come during the day. Morning you might have different type of customers, afternoon you have different types of customers, evening different types of customers, so they change the product. Okay, daily they change the product. Morning 8 to 12 they'll have different product, 12 to 5 they'll have different product, 5 to 10 they'll have different product, based on the kind of customer that are coming in, because they don't have large space, so they can't put everything, right, like a big stores like we have, but they will use small space to rotate the product. So they figured out that milk and beer, there's high association, and they started putting them together, and the sale of beer increased. Generally they used to put beer in the evening, but then now they started putting beer in the morning itself. So what happened was, they figured out that generally in the morning, family will send the male uh, out to buy bread or eggs and things like that. So these guys would anyway come out in the morning to buy bread and milk, right? So they think that, okay, if I need a beer, I have to come again in the evening. So instead, they'll buy beer along with milk, bread, eggs in the morning and keep it in the refrigerator, right? Evening they will drink. So so that's how, if you'll be able to increase your sales, right? So that's an example of market basket. Any questions so far? Okay, it's only me talking. Any questions? Or how is it? Is it according to what you wanted? Is it aligned with your expectation? I just want to have a quick feedback.
Yes, sir.
Okay, so you expected same thing, right? Or do you wanted something else for me, from for me to discuss about? Any questions you have? No?
No, sir. We are going.
Okay, great. So it's 11:44. Can we just take 2 minutes break? We'll meet at 11:46. Okay. So now it's 45. So 11:47, let's connect. Okay. I'll just take some water and we'll continue. Okay. Talking about this. So I have 4 more examples to talk about. And apart from that, then I have 2 more examples to show. Okay. And then we will end it. Okay. So just let's, be back at 11:47. Thank you.
Sure, sir. Thank you.
Okay, I'm back. Any questions before we continue?
Yeah, participants, please respond, ma.
So as I said, right, I want it to be more lively. You can ask me any questions. Um, okay. If you don't ask, then I'll go with my slides.
No doubts.
Okay, perfect. Now, see, these are the four main algorithms. Okay. Now, whatever we have is kind of reusing same kind of concept. Okay. And again, the complexity can increase. As I said, each of these families will have many algorithms in itself. Okay. So what we are just talking about is the groups or different types of algorithms. Okay. Or families of algorithms. Right. So then we spoke about semi-supervised. Okay. So let me start from the example from bottom to top, and it'll be easier to understand. So you have text classification. Okay. So text classification example of semi-supervised. So here you give handwritten text, and then it will classify, or it will read it'll convert the handwritten into electronic format, right? So you write ABCD, and then you want algorithm to read ABCD, okay, and then convert it into electronic format ABCD, right? So most of the records that government had, right? Government will have records for hundreds of years, right? Now those were written on papers, and papers will get spoiled, and so they are trying to convert this into e-copy, right? So that they can put it in electronic format, and then it can be saved for many more years, isn't it? So you are having a machines which are able to read your text, okay, and convert it into this. Now problem here is, okay, everybody has different handwriting, correct? So you cannot, it's difficult it's not we cannot, but it is difficult for machine to understand how it looks like, right? The way all our handwritings are unique, isn't it? And just like we have a unique fingerprint, our handwriting is also unique, isn't it? So so first thing is, okay, it has to it in the sense the machine learning algorithm has to first understand that these images, because when you give handwritten notes, the images, right? So these images are similar in nature. So when you write A, my A, your A, everybody's A should be grouped like similar in nature. Okay, because your O and A, small o and small a, might look something similar, right? So first thing, okay, it has to do is, it's a two-step process. Okay, it has to first understand that, oh, all these are A's, okay, or all these are similar, not A's, but all these are similar. So when you say all these are similar, we are trying to use unsupervised learning clustering. Okay, you group them together. Now you have to give it a name, right? So then you apply classification on this. So it's not just clustering, it is clustering first, where you are grouping all A's together, Z together, O's together, 1 together, 5 together, and then you have to also give it a name. So that's why it is classification. Ultimately, at the end, it is classification, but it is not a strong classification. First, you have to perform clustering, and then you perform classification to call it A, B, C, D. Second example is lane finding on GPS data. Now, GPS, when you switch on GPS on your phone and you are driving, let's say using GPS on, GPS has to find the different um, land masses, right? So when you're going, it should be able to know that this is the road, okay, this is grass, this is playground, this is water, right? Your GPS will not take you into water. It knows that, okay, there's a water here. So first thing is that it has to know how a water will look like, how a ground should look like. Okay, when you know how water should look like, ground should look like, that's your classification, right? Weak classification. And ultimately, when you go, when GPS is taking, okay, and trying to understand, read the different land masses, it has to then tell you that, okay, this road and the road component is alike, so it will keep you on the road itself. Okay, and then where there's a left turn, okay, it knows exactly where to take left, right? It knows that it has to take left, but have you exactly reached to a point where you can take left? Because the left road and the straight road, they matches. So then GPS knows that, okay, since this matches, there's a possible left here. Is this the left? That's the algorithm, okay? But where exactly to take left, your GPS will tell you. So again, ultimately you are starting with classification. We're classifying road versus non-road, or where you can drive, where you can't drive, and then grouping it with road only, right? So then it says, okay, take left here. So again, same concepts, you are mixing them together and coming up, finding out this. Reinforcement learning, right? So reinforcement learning is different. Okay, as I told you, it's feedback based learning. So in feedback based learning, you have optimized marketing. Again, we call it classification, but the way it works is different. Optimized market. Let's say you are a marketing manager of Airtel. Airtel decided that hired you as a marketing manager, and they give you 100 crore budget. They say, okay, take this 100 crore budget. You plan my advertisement for entire 1 year. So you will not take 100 crore and put it in TV, or you put it in social media ads, or on print ad, TV ads. You don't do that. What do? Okay, out of 100 crores, you will take only 10 crores. Okay, you will not touch 90 crores. 90 crore is there as your budget is there, but you will take 10 crores. Let's say first time you have never done anything, you have no idea about what marketing is. Okay, not sorry, you are a marketing manager, so you know what marketing is, right? But you have no idea what kind of returns this segment gives, right? Because as a marketing manager, your objective has to maximize the benefit, maximize the sales that your businesses will give you, okay, based on your investment, right? Why do we do marketing? We invest in marketing because that marketing will someday in future will give us more business, right? Otherwise, why would anybody put in marketing, correct? So okay, so you have no idea, you don't know which will give you more business. So you take 10 crore and you identify 10 channels, okay, TV, print, radio, Google ad, Facebook ad, you know um, um, uh, multiple channels, okay, and then you said, okay, let me put 1 crore in each of these 10 channels. Okay, channels means different mode of marketing. So you give 1 crore to all the 10 because you had no idea, you don't know which is doing better. So you give 1 crore to all and you evaluate for 15 days, 20 days, 30 days. Okay, which is so generally, when you go, sometimes they ask you, how did you know about us? Because they want to know which marketing channel is working. So if all of us say that we came from Facebook ad, what company will do is invest more in Facebook ad, right? So they invest in all these channels, and then after whatever, right? If they invest for 15 days, so after 15 days, it will wait for the thing channel, ads to run, and then when ad is done, they will evaluate the impact. Okay, did it impact? Did it give me more business during that time? Through which channel we got more customers? Okay, and on online it is very easy. Okay, again, if you get into digital marketing, you will know that there is a option where you can embed a certain text in your URL. So when somebody clicks on the URL, you know that, okay, this click has come from Facebook or Google or from Amazon, or from what is the source of traffic to your website. Okay, physical it is difficult, but you still have to ask them, understand, okay, what is working. So now after 15, 20 days, when you start realizing, you figured out that, 70% or let's say 40% of business came from Facebook. Facebook was the most successful campaign that you did. And putting hoarding, okay, gave you very or almost no business, right? So next time, so this is the feedback you're getting. So you took some action, okay, without any knowledge, you did some action, maybe with your past knowledge, you did some action, and after that, you are trying to read the feedback. And feedback says Facebook was super duper successful. Hoarding was kind of it wasted your money. So next time, next month, again you take 10 crore. You will not take all 90. You'll take 10 crore. This time you'll put more on Facebook. You'll put 1.5 crore in Facebook. You will not put again everything in Facebook. Okay. Last time it worked doesn't mean that this time also it will work. So you will put more money in Facebook, and very least, not that you will drop the channel. So the hoarding, right? You'll still put hoarding, but last time you put 5 hoardings. This time you'll put only on 2 hoardings, maybe. Okay, so you are changing your allotment, okay, the budget allotment based on the last month feedback. So your decision is based on the feedback, right? We don't have past data, or okay, what has worked for Vodafone may not work for Airtel. What has worked for some other company, let's say bank, may not work for Airtel, right? What worked for Ratnadeep may not work for, or what worked for retailers may not work for your Airtel. So you have to figure out what works for your business, for your department, right? For your kind of campaign. So that's where you are not investing fully. You are investing a little bit, getting the feedback, and then again you invest. Again get the feedback. Again you. If constantly Facebook is giving good result, constantly you will increasing the allotment in Facebook. Okay, that's called optimized marketing. Your marketing every step, every month marketing that you're taking or you're doing is based on the past month feedback, and you're optimizing the cost of your marketing, so that when you are 5-6 months down the line, your impact or the benefit that you're going to get from marketing is a lot more than what you got in first month, right? So that's your optimized marketing example. Then you have driverless cars. Driverless cars are again concept based on feedback, okay, reinforcement learning. Okay, see, when we see a red signal, we put a brake, right? Why do we put a brake on red signal? Okay, not that we love to obey rules, right? Not because that. Okay, you either put a brake because you know that if you don't put brake, you're going to hit someone, or you're going to hit, right? It's going to have impact on health, right? You'll have an accident, and you don't want to do accident, right? Or you're scared that if I don't stop, cameras will catch me and I'll get a fine, right? These are the two reasons why we stop, right? We are scared of accident, or we don't want to pay fine to police, traffic fines. So you stop. So that's the feedback. If I do this, this is the output. If I do this, okay, I will get negative outcome, right? Like chess game, right? When you play a move, okay, if I do this, I'm going to lose. So you will not play that move. If I play this, I will put pressure on my opponent. So I'll play that move. The same thing. Okay. The way you accelerate, when you put brake, you take left, you take right, because you have a goal in your mind. Let's say you have, you have to go from point A to point B, right? And it takes only 10 minutes to go, but you have 40 minutes to cover. You can take a long route, right? You can take a long route and go there. But if you have only 5 minutes to cover the 10 minutes, you'll take the shortest possible route and you try to accelerate faster, right? So our action is based on the objective. We always, okay, the reason you are here is because you think that you are going to get something, okay, either knowledge or maybe attendance, whatever, right? So that is the whole motivation for doing something. That's what your reinforcement learning is. We look at the objective, okay, and the objective is, you know, uh, according to what I want, I will do it. If it is not, I will not do it, right? So driverless cars is being made on this concept of reinforcement learning. Okay, so any questions so far? Okay, so what I'm going to do for next 30 minutes is I have identified 2 problems, okay, and we'll see how to approach, how to apply machine learning algorithm on the problem. Okay, so this is the first problem. So it tells you that you have been hired by an e-commerce company, okay, online company, and they are based in New York, and they sell clothing. So it's a soft line. We call them soft line or clothing store. Okay, and they of course they have in-store styling and cloth advice sessions. Okay, um, and they also have business on their website, online business on their website and mobile apps. Okay, so no, so they have in-store, right? They have their own store. They also do business through online, okay, through website and mobile apps. Now what they want to do is they're trying to decide whether to focus their efforts on their mobile app experience or their website. Okay, they're thinking, should I invest money more on mobile app? Should I create more features in my mobile app, or should I focus on developing my website or making it more user friendly, invest in mobile website, or should I invest in both, right? So they asked you a question and they want you to figure it out. Okay, now any comment, which algorithm do you think we'll use? Okay, so among the ones that we have discussed so far, what type of learning we are doing, what type of algorithm should we use? Any case, any suggestions, whatever. Okay, don't be afraid of getting it wrong. Okay, we are here to learn, right? So if you get it wrong also, it's fine. Okay, in supervised learning it's okay to get wrong. Okay, or for that matter any learning, right? We are learning, that's why it's okay to get wrong, and that's what we'll see in the algorithms also. Algorithms are also not scared of getting wrong. Okay, yes, we need to improve. Okay, if you get it wrong, next time you should not get it wrong. That's the objective, but first time you can get it wrong. So what do you think? Anybody wants to have any comment? Maybe teacher can give you extra mark if you talk, if you speak. No, marks will not motivate to speak. Okay, anybody? No? Yes? So you understood the problem at least, right? So problem is they've hired you. They want you to tell them that, okay, they say, okay, whatever data you want, I'll give you. But tell me, should I invest in website or mobile app, right? Okay. So see here, when you get this kind of problem, you first thing is what approach you will have for the solution. How do you approach this? Okay. So maybe, at least in the example which I have here, what I'm trying to do is I'm trying to see the impact on the sales. Okay, which is giving more impact on the sales? Is it the website which is giving more impact, or it is mobile app? Okay, so again, taking it, it is similar to the marks and your number of hours you study, right? So so you want to see if uh, studying for more number of hours will give me high marks, or watching more number of Facebook will give me marks, right? Question is, I have an exam, okay, and I want to score very high marks. Should I spend my time watching TV, or should I spend my time studying? So you need to figure out that studying will impact you more in getting higher marks. So you should spend time in studying, not in watching TV, right? So just to very connect it to a very smaller level so that you can understand, right? So my goal here is to find the sale which will give me higher sale. Okay, sale is your number, right? So number means it is first type, regression type of algorithm. Supervised learning, because the data is given, you can see the data, you can go back and see the data that is, or the sales that is happening on the website versus sales that is happening on the mobile app, right? So you can go and look at the sales and see if it's a mobile app sales or it's a website sale, isn't it? So you have the data, right? Past data, you have it. So it's a supervised learning, and your prediction is about the sales from a website or from uh, uh, app. So it becomes your regression algorithm, right? So how do we approach? So first thing is that you look at the data. Okay, step one, get the data, isn't it? So here you have got the data. Okay, so there are 4 important columns here, which apart from, of course, you have more columns. Okay, so you have email address, credit card information, all those things, but things which are important. Okay, garbage in, garbage out, right? So you don't want to put garbage in, you want to put things which are more relevant. Okay, so you figured out that it has a lot of data. It has data like average session length, time on app, time on website, length of membership, etc. So you get the relevant data. Okay, get the relevant data, step 1. Now step 2 is talk to the company, ask them what are the columns, which factors, which features, okay, are important for them to analyze this. Since most of the people who are see, it always, experience will always, okay, do better than machine. Okay, if experience is not there, if you are unsure, or if you want to verify if what experienced person has said or not, or what said, you will use statistics to validate. So we will use statistics. Next step 3 is we'll use statistics to figure out which columns are important, which features are important. But before that, you need to talk to them and see what they say. Okay, sometimes they might say wrong, so you can go back and say, okay, you said this, but this is what we found. Tell me if you are wrong or we are wrong, right? So always talk to the company, understand the data. Okay, then, okay, you perform your own analysis. So we call them exploratory data analysis. Okay, exploratory data analysis is about performing different graphs, different statistics. Okay, in this case, what I have done here, I have performed correlation, okay, between each of these columns. So correlation is performed on numeric columns, isn't it? So I have taken average session length, time on app, time on website, length of membership. Membership means the number of time that the people have been, or the customer have been member of your store. Okay, and finally this is the yearly amount spent. Okay, so this is the yearly amount spent. So this becomes our target. This is our target, right? And you see the relationship between them. Okay, target versus first column is average session length. So this is your target amount spent on y-axis and average session length on x-axis. So if you see, there is a positive trend. Okay, scatter plot. These are scatter plot, right? This is scatter plot. This is histogram. So when it is A versus A, it is histogram. When it is A versus B, it is scatter plot. So if you see here, there is a positive turn, right? Okay, or positive relationship between average session length and yearly amount spent. So as you spend more time on internet, or whether it's a website, or it doesn't tell you, it's a combined, right? So it's combined time that you have spent on website and mobile apps. Okay, so you see there's a positive trend here. Okay, now again, if you see time on app, you can see a positive trend here, right? As time on app increases, your the output also increases, right? There's a positive trend here. There's a positive trend here. Now time on website, you see, okay, here also there is a positive trend. But if you look at the data, okay, this is all widespread, right? This is more, it has a higher correlation. Okay, this also has higher correlation than this one. Okay, this also direction wise is a positive direction. But again, if you find a correlation will be maybe around 0.6, 0.65, not higher than that. Okay, so it is going in same direction. It's a positive thing. Okay, that means number of time that you spend on website also helps you to get more return, but it is not that strongly correlated. So you can actually see from the analysis itself that time on app is more important than time on website. But if you see this length of membership, okay, is very strongly correlated. It's very thin. Okay, so out of all these 4, now you can see that all these 4 impacts your annual revenue or total revenue that the customer is bringing to your store. Okay, and if you have to predict, length of membership is very strong. Okay, there is a lot of correlation between length of membership. That means people who are with you for longer time will buy more from you than people who are near to your with you. Okay, session length is also strong. Time on app is also strong, not very strong. Very strong is only one. And time on website is weak. We say weak. We don't say no relationship because there is a correlation, but correlation is weak, isn't it? So this itself tells you a lot of stuff, and this is important part. Okay, explorative data analysis, EDA we call them, is part of your analysis. Before you get into detailed analysis, you have to perform, okay, and then try to extract some meaning, okay, some sense out of it, and then you go and talk to them. Okay, now you go and talk to them. Now you see if it is yearly annual spend, okay, on Y, right? You have yearly annual spend. Now let's say instead of yearly, if it was total amount spent, total lifetime. Now in that case, okay, this would have given a different meaning. Obviously, the customers who are with you for longer will buy more product. Okay, so that data is of no use to us. Okay, that is not in that case length of membership is of no use to us. Okay, because it's not apple to apple comparison. Now there's someone who joined only 6 months back to your store and gave you 1 lakh of business, than someone who is 10 years old in system but given you only 2 lakhs. But what it will show, this will show 2 lakhs, right, higher. But typically that guy who has joined 6 months back should have higher this thing. So again, you have to make sure that the data that you're comparing, does it make sense or not. In this case, we call such things as dependent columns. Okay, because your length of membership and amount that you spend, total amount that you spend, are dependent column. More you spend time, more money you will spend. So that's a dependent, that's not a factor which you need to consider for prediction. So these are your X, right? Amount spent is Y, and these are your X. These are your X. Okay, so X and Y should be correlated, not dependent, right? So if I have to predict number of vehicles, okay, and we know that generally number of tires, okay, is 1:4, right? One car will have 5 tires. So that is not the data that we need to predict for how many cars, right? If you say that how many tires you have, 5,000 tires. So okay, so it is 1,000 cars. That is a mathematics. That's the first type of mathematics, right? Deterministic mathematics, normal programming. Okay, where x equal to 5x. X equal to 5x is not algorithm, right? Machine learning algorithm is where there has to be some element of uncertainty, right? Some element of uncertainty. There's no uncertainty there, right? So if you have data like that, we exclude it, that we don't consider them as part of machine learning. So yearly, annual, yes, then it makes sense, right? Maybe whose system for long may not spend more with you, but it shows that they are spending more. So this becomes important metric for input into our prediction. Then from here, so step 1 to 3 is easy. From step number 4, your machine learning starts, right? So first step that we do is, we again in machine learning algorithm, step 1 is we split into training and test set. Now can someone tell me why do we split into training and test set? What is the purpose of training that splitting the data into training set and test set? Or what is the purpose of training or test set?
To check whether the input which is given is performing accurately or not.
Right.
Metrics, performance.
Right. So again, if I have to compare it to our class learning, it is like, a teacher teaching you for 3 months. Okay. When they teach you, they'll give you all the concepts, right? They'll tell you all the concepts. That is training. They're training you with both question and answer. They'll tell you, questions also they'll tell you answer also. But that exam that they keep, right? That one exam, okay, is to test your skill, how much you have learned. So when we have this data, okay, X and Y, and here we have multiple X, right? We have 4 X's. So what we do is we keep a small portion. In this example, it is 30%. Test side is a Python code, so test side is saying 30%. So 30% we are hiding from the student. If I'm a teacher and if my knowledge is 100%, I'm hiding that 30% from you. I'm giving you 70%. Okay, and that 30% I'll ask you in the exam quiz. Okay, to see whether you have, because if I give you all 100%, then I don't have anything else to test you. So I'll keep the 30%. I'll give you 70%. I'll test you on the 70%. Sorry, I'll train you on the 70%, and then I'll test you on the 30% knowledge of mine. And then I'll tell you, okay, you have understood that concept or not. Okay, so when you have a lot of obviously you will keep smaller data set for testing, right? You won't keep 70%, but you keep 20%, 30% for testing. Okay, so now if you have 1000 rows, 300 rows is hidden, and we take only 700 rows for machine to learn, right? That's the experience that we are giving. We will give that 700 rows to machine to learn. Okay, so that's why the purpose of training and test set is that you train the model on training data, and you keep that extra data for you to test how the model behaved, right? How the model behaved. Okay, so that is step. And now the next step is you need to choose the right algorithm. So we know it is regression. Okay, but within regression, which algorithm to choose? And we have many algorithms. Okay, one of them is linear regression. The most basic is linear regression. Linear regression will form a output like this. Okay, so y equal to the constant plus your coefficient 1 of variable 1 plus coefficient 2 of variable 2, so on, right? So p is nothing but the number of features that you have. So in our case, okay, we will have in our case it is y equal to, okay, b0 or c, you can say constant, plus m1 x1, right? m2 x2, m4 x4, and plus this epsilon. What is this epsilon? Again, you have to go back to your intermediate level. What is this epsilon?
To check if any error is there.
Yes. So if you talk about this is the equation except epsilon. This is your, the model that you have derived, which is this, right? So this is your regression line. The red line that you see is your regression line, and this is your constant, right? This is your constant, C here, and then this is your slope. M1 is the slope, right? Now we can only see 2-dimensional on the graph, but here we have 4-dimensional image. So imagine, you have a 4-dimensional image, and this is a not line, this is a big plane which represents in 4 dimension, and that's the slope in all the 4 dimension. But you see, okay, the data ranges from here till here. Okay, not all dots are on the same line. So this error is your epsilon, right? You are not going to get perfect answer. I just said, right, when you're trying to predict, you cannot predict something perfect. So if you're able to predict something perfect, there's something wrong. Okay, it's not prediction. It's only a mathematical formula that you figured out, and okay, but you're not predicting it. Okay, epsilon. So now again, going back to the CDA. Okay, in the last row, which one will have the smallest epsilon and which will have the largest epsilon value? Amount spent versus what will give you minimum epsilon and which will give you maximum epsilon. If you just look at things individually, that epsilon represents all 4 dimensions, right? But if you look things individually, which one will give you? Time on website will give you larger epsilon value, right? If you take this as regression line, the value ranges from here till here. So you'll have large epsilon here, and length of membership will give you minimum epsilon error. Okay, so you have split and you have decided to choose linear regression. Okay, and these are the 3 lines of code. Okay, so you run this, and then what it gives you is the algorithm. Okay, you're running the algorithm. Okay, running the algorithm is easy. You're training the algorithm. After training the algorithm, you get this output. These are the output. That means these are the coefficient M value, right? So this is M1, this is M2, this is M3, and M4. Okay, average session length 25, time on app 38, time on website 01, length of membership 61. Okay, so now when I form this equation, y equal to M1 plus X1 plus M2 X2 plus M3 X3 plus M4 X4 plus, okay, constant plus epsilon. Which will, do you think, which one will have a maximum impact on Y? See, all these are directly proportional to M, isn't it? Okay, so if you change a little bit in first value, okay, it is going to increase by 25 times. This is going to increase by 38 times. This is going to increase by only 0.2 times. You know, very little change, almost no change. This is going to increase 61 times. So you see that time on website has almost no role to play. There is some role, 0.1 to 0.2. Okay, but not as compared to these things. See, 61 length of membership is very important. That means if you have an old customer, you should not make them unhappy. The contribution that older member is giving you is much higher. Okay, 1 year old itself will give you into 61 times the revenue, right? So the data tells you that this one length of membership is having very high impact on your outcome, the sales, right? That's why when you have to take extra care when your old customers are not shopping, call them, check with them what's wrong. Maybe there's something wrong that has happened and they're unhappy and they're not buying. Okay, so if you have data in front of you, you know what action to take. Okay, next best is time on app, 38 times. Okay, one small change, one small extra hour will have 38 times 38 rupees. One extra hour person spend, 38 rupees you're getting extra from that customer, right? Here you're getting 61 rupees, here you're getting 38 rupees. Okay, here one extra hour is going to 20 paisa, right? So you know that app is important for you. You need to spend more time and effort on building apps. Website is probably you can ignore. It's not zero, right? It's not zero, or it's not negative. Negative means more you spend time on website, they are not buying. In that case, you'd better shut down your website. If you had got a negative coefficient, that means people spending more on your website are deciding not to buy, right? So either you improve your website or you close on your website. It's not helping you. It is helping, but very little, almost like zero, negligible, right? So now based on this data, I know that I need to, okay, greater the value, more it is related to the target variable, right? So I need to spend more focus on mobile apps, isn't it? This is what it says. But we don't stop it here. That's not all. You have to again go and evaluate. Okay, what you have figured out, is it correct? Okay, how well it holds true. So we have something called as absolute mean error, mean squared error, root mean squared error. And you can go and check for these values. What does they mean? This so you're trying to calculate how much error is there in the calculation, and RMSE for this data is 8. Okay, more higher the value, bad is your process. You want RMSE to be lower. And what we did was we just used one algorithm to find this data, find the output, right? You can, in generally, right, you'll have to run multiple algorithms and then look at the evaluation. Look at this RMSE. The algorithm that has minimum this, okay, you want RMSE to be as low as possible. So algorithm that gives you minimum RMSE is the algorithm that we preferred. But then again, you have concept which I'm not going to talk about, which is like your overfitting and underfitting. Just make sure that you are not overfitting or underfitting by changing the parameters. Okay, so two things. One, your aim is to improve the accuracy or increase the accuracy or decrease the error. RMSE is the error. E stands for error, right? So error means what? It has to be less, right? So if you see error component, that it has to be as low as possible. So run it with multiple algorithms and see which gives you least error. Not only that, every algorithm will have different parameters. Okay, in multiple regression, we used 4. Could we have used 6, 8 algorithm, or sorry, features, or should we use only 1 or 2? Okay, that will also impact your RMSE. One, that again, so not only algorithms but parameters within the algorithm also you have to look at to make sure that you get a perfect or correct outcome, right? Any questions so far? So this is the entire life cycle of approaching a problem, and approach is always from business perspective. Okay, it has to be about how it helps the business, right? Your approach is from business perspective. The output that you're going to get has to impact the business itself. Okay, so you do all this hard work, you do all these calculations and all, but ultimately this is what is required by the business. Your company wants you to tell whether it will impact mobile app or website. You say no, 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 website is almost no use to us, focus only on mobile apps. Okay, to make that statement we have done all this. Okay, so there's one more example here. Okay, I'm not going to get into details. So Bob started his own mobile company. He wants to compete with Apple and Samsung, but he doesn't know how to price. But he figured out that the RAM, the internal memory, these are some of the factors which impacts the price. So he wants to find, he doesn't want to predict. Okay, see, if his objective was to predict exact value of the phone, then this would have been a regression problem, because output is a dollar, right? Continuous numeric value. If the purpose of Bob was to find the exact pricing, okay, then it is a regression problem. But what it says is it wants to find a price range. Okay, so he wants to maybe have low, medium, high, very high. Okay, these 4 categories. He wants to have 4 categories of outcome. So based on the RAM and memory and other factors which impact the price of Apple and Samsung. So again, for my product, I don't know the pricing, right? I'm to arrive at the pricing, but I know how Apple is pricing. I know the Samsung pricing. So I'll take their components configuration and the price, and I'll create a relationship between them. I'll create a pattern between the component that Samsung uses and the price that they charge, and I'll use same pattern to come up with my own pricing. So this will tell me which kind of components makes you a low price product. Okay, which kind of configuration makes you a higher kind of higher valued mobile phones. Okay, any question on the question on the problem statement? And first step, as I said, get the data and perform the exploratory analysis. Exploratory analysis will tell you, okay, the relationships. You know which columns are affecting your price. Okay, and then you select those column. Okay, so again you see here battery power, color of the mobile phone, clock speed. Okay, and this is the price range. So you can see this is positive. Again, this is almost like 0, no impact. Color doesn't have impact. This is again no impact, almost 0. So this is a correlation value, right? So you figure that out and then you build your model. Okay, you build your model. Okay, so again you're breaking into training set and test set. We are going to use nearest neighbor. Okay, k nearest neighbor. So here, if you again we can discuss this maybe some other time. So using this algorithm, you figured out, you ran the algorithm, k nearest neighbor, this is how you run it. Okay, and it gave you outcome. This is the output. Okay, it says if these are the input values, then it has to be in price range 1. Price range 1 is low value. So if these are the configuration, you have to price it low. Okay, if these are the configuration, your price has to be moderate, right? It's moderate. Okay, so for each of the combinations, you have got a range. Now you know, so you figured out what configuration you have. Let's say if your phone has this configuration, then you have to price your phone at moderate cost. Okay, and the accuracy is described here with this one: precision, recall, F1 score, and support. Okay, and in this case accuracy is 54%. Accuracy 54% is not good. It's a poor. That means this algorithm is not suited. You have to change the algorithm. Different algorithm you have to apply here. Okay, accuracy as high as possible. Just like you have RMSE there in regression, RMSE has to be as low as possible because that's a error component. Here it is a accuracy component. So accuracy has to be high, as as high as possible. Okay, and then it has its own set of metric that we need to understand and perform the analysis. Okay, so that's all I had for today. Any questions before we wrap up?
No, sir.
That was
Was it
wonderful,
according
sir.
to your expectation? This is what you expected from this lecture or something else? Do let me know, okay? Do give your feedback.
Sir, this is Dr. Prashant and I have small query.
Yes, sir. Please tell me.
Sir, when will we go for overfitting and underfitting problems? Sir?
Okay. So first we need to understand what overfitting is, underfitting is. Okay, I'll take maybe a minute to talk about it and then we'll tell you when to look at it. See, overfitting, okay, is like where sometimes in physics lab, as in intermediate, we used to calculate the G value, right? So we all know the G value 9.8, correct? So what we used to do, like we're supposed to perform some experiment, get the amplitude, and then calculate G, right? But what we used to do, back calculate, isn't it? Okay, if 9.8 is there, and if this is the length of the string, you have to amplitude should be this, and then so you get perfect 9.8. Okay, that is called overfitting. In machine learning, you are providing too much of data for overfitting. Okay, what it means is, let's say as a teacher, when you have to give some student will ask you, give me some important questions to read. So if you give all the important questions to read, then what happens? The student will not use its brain. The student will try to mug up. Okay, will try to by heart the answer. Okay, so if I give if I give lot of data for training, okay, when you have very large data, okay, see, as we said so far, that as you give more and more data, accuracy increases, right? But what happens if you consider this analysis? Okay, your training accuracy will increase, no doubt, as you give more data. So this is your, let's say this is the data, okay, number of rows, okay, as you give more data, and this is, let's say, accuracy. So your accuracy increases, right? But in true form, what happens is, after some point of time, okay, machine doesn't start, okay, let's say if input is 2, 2, 2, 2, and output is 6, and again you have 2, 2, 2, 2, 2, input, output is 8, or let's say 6 only. Okay, now if you have this kind of data, and if you're asking machine to predict for 2, 2, 2, 2, 2, because when you provide a lot of data, that means you are providing almost all the possibilities to the machine. Now in this case, machine says, Array, you gave me 2, 2, 2, and answer is 6. You gave me 2, 2, 2, answer is 6. And you're again asking me 2, 2, 2, answer is 6 only. So machine is not using its brain, trying to mug up by heart your input. But you don't want this. You want machine to take this input and find the hidden pattern. Okay, find the hidden pattern, which is using the algorithm that we provide. Okay, and sometimes it should be able to get 5.5, sometimes should be able to get 10.5. Here it might give you 6.8 as answer. Not exactly this. So you are forcing computer or the algorithm to by heart the answer, not give you the right answer. Okay, so when you talk about training algorithm and test data, right? So when you perform training, then you find RMSE for training. Okay, RMSE for training, and then we also find RMSE for your test, TS. Let's say TS is test. Okay, now if you have 1 lakh data, okay, and your possibilities, data possibilities are very few, don't give 1 lakh data. You give only 50,000. You give only 20,000. Okay, because if you give too much of data, your training accuracy will go on increasing. Training accuracy is going on increasing because if you give more data to your student, everybody will score very high marks. Okay, but what happens when they are tested, when they go for interview, they fail in the interview. Okay, they have 90% marks, 95% marks in internal exam, but they fail in the interview. Okay, so it's like this: you're providing a lot of data, so algorithm is accuracy for the training is increasing, it's keep on increasing, but your test accuracy, okay, test accuracy will always be less than training, right? Because you are testing it, so it increases. After some time it starts decreasing. Okay, so this portion is called underfitting. Underfitting is where you have very less data. So when your model is underfitting model, we say that means if you're providing data to it, the model will increase its accuracy. Okay, both training and test data. So to know how well your model is performing, we need to find RMSE with both training data and test data. I just showed you with one. Okay, but you have to find error and or accuracy, whatever you're finding, with both training and test. Okay, if you see that both are increasing, that means yes, you are underfitting area and you have to keep increasing the data. After some time, what you'll see is the accuracy of test is going down. Accuracy of test is going down. Accuracy training will always go up as you give more questions to student, they'll score more marks, but they started failing in the job interviews. That means this is the optimum level of data that you need to provide. Okay, this is the data that you provide. This is data, right? So this, if n is 1000, that means you need to provide 1000 rows to that for machine to give you best result. If you provide more than 1000, machine is trying to by heart and not able to perform analysis. If you give less than this, that means your student is not getting enough content to read. Okay, so underfitting is where your accuracy both training and test is low, and if you give data it will keep on increasing. And overfitting is where the difference between training and test accuracy is very large. Training is like 99% accurate and your test is 70%, 60%, 50%. So this is the region of overfitting and this is the region of underfitting. This is the optimum level of data that you need to provide to your algorithm to work. So how much to teach your student, right? How much can you teach? You have to teach optimum so that they start using their brain, not they start by hearting the answers that you give, isn't it? So that's how the overfitting and underfitting impacts the models.
Thank you, sir. And last one more question. As per
Sure.
your in your industry knowledge, what is the splitting ratio? Which ratio is good? Because in our student project, we are doing trial and error method like 60-40, 70-30, 80-20.
Right. That is the only way, sir. Okay. Okay. Generally, we also have to depend upon the kind of data that you have, right? If you have perfectly balanced data, then doesn't matter. Okay, we don't see much of a difference between 25, 30, 20%. But if data is unbalanced, okay, where like credit card data, where one set, like you have 1000 rows, and in that training set, yes is like 800. Okay, and why yes is 800 and no is only 200, right? So you don't have we have unbalanced data. So in this case, what we try to do is we try to remove some data from here, and then you will have, when you remove, then you'll fall under this scenario, right? So in that case, we try to take less number of less percentage, okay, 10%, 5%, 15%. But if you have lot of data, right, say you have 10,000 data and both are balanced, we try to take maximum number of we go to 30%, 40% for test data. Okay, that is another way to balance your data. Okay, so that it doesn't go into either this side or other side. Because if you take more data on training, you'll have less data for testing. Less data for training. So you get into underfitting. If you take less data for test, if you take less data for test, you'll have more for training. So it might get into your overfitting side, isn't it? So that's the way you have to do trial and error and then find out which is the right model. So your pre-processing step is lot more time consuming than algorithm. Algorithm is 3 lines run, done, output done. But your pre-processing and then post-processing to go back and again give the output to your pre-processing step will take a lot more time.
Okay, thank you, sir.
Sure, sir.